Okay, one more, stop. 1.5.
Yep.
And
In the last
stop at
episode of
5,000.
Bigger, Higher, Faster, we brought you glimpses of my sortie on the Dassault Rafale.
Roll it to the right, and pull it, continue pulling, rolling to the left. Yes. Okay, now you can turn right. I put some power.
Okay.
190 degrees left.
Okay.
And we will go perfect. You can climb now, climb the aircraft. Pull it. You see, you are... It's like a flight simulator.
It is.
Very easy.
The French superfighter, the winner of an Indian Air Force flyoff featuring some of the world's best jets. If negotiations end up in a contract, at least 126 Rafale jets will eventually enter service with the Indian Air Force in a 90,000 crore rupee defense deal, likely to be the world's largest. During my sortie, I got a chance to check out the systems on board the Rafale.
Are you comfortable, Vishnu?
Yeah, I'm comfortable.
That's good.
Its ability to strike air, land and sea targets on the same mission if
Okay,
necessary.
we have
Its terrain following radar, which allows the jet to soar just 100 feet off the surface of the land or sea.
We go back in the valley.
Yeah. Nice.
Its superb cockpit interface with easy to understand multicolor display and a heads-up display with all flight critical information at the eye level of the pilot.
Okay, this is beautiful.
Oh, it's lovely.
When 23 knots of the impact, so we can brake.
It was an exhilarating experience, an opportunity to check out systems and technology which could be at the front line of the Indian Air Force's defences in the years to come. For me, the opportunity to fly on a Dassault Rafale is particularly special. Just as the Kargil War wound down in 1999, I had the opportunity of flying the Dassault Mirage 2000, which the Indian Air Force has used for many decades. On that occasion, we were actually on the same Dassault planes which were involved in the bombing of Tiger Hill and other areas. There is, in a sense, a great deal of similarity between the Mirage 2000 and the Dassault Rafale, but there is also a great deal of difference. But the design philosophies of both the aircraft have a lot in common. They are both designed to be very simple and easy to maintain and very simple for pilots to use. And even though there's been a quantum leap in the level of technology in the Rafale, it maintains the philosophy which Dassault has always had on its aircraft. Make planes simple, make them easy to operate so that pilots get the optimal information they require in hitting their targets. But technology is all very well. How exactly does the Rafale work as a war-fighting system? To know more on that, I travelled to a major French Air Force base in Saint-Dizier, a few hours' drive from Paris. There are 3 Rafale squadrons here, including one that helps to maintain France's nuclear deterrent. Pilots here are, quite clearly, the most experienced Rafale pilots in the world, and were the first pilots to take their jets into action when the call came to strike at targets in Libya. They've also been deployed over the skies of Afghanistan. When the initial call to enforce the no-fly zone over Libya came in March 2011, pilots of the 1x7 squadron flew straight from Saint-Dizier to the skies of Libya. Refueling several times mid-air, the initial missions ended up lasting up to 9 hours before the French offensive was deployed to bases in the Mediterranean. Lieutenant Colonel Patrice Hougret, now commanding the 1x7 squadron, was among the first pilots over the skies of Libya.
Operate from Saint-Dizier to Libya, so as you said, more than 2,000 kilometers. A long flight. We did it with air-to-air refueling, of course. We did it with all the assets necessary to the operation, AWACS, and also by the tankers, and we did it well. It was for my own experience the first time I flew flight up to 8 hours, so new experience, but it was alright.
In their missions, pilots of the 1x7 used an array of weaponry, from long-range cruise missiles to a remarkable new weapon called the AASM, or Hammer. A smart bomb with an exceptionally sensitive seeker, the Hammer glides to its targets a long distance away and can actually maneuver if those targets start moving.
We call it A2SM. The body of the bomb is quite normal. Actually, it's just a 500 pounders, 250 kilograms bomb. And then on this body of the bomb, we add two things. First, here we had an acquisition for the target that will help guide the bomb. This head here is GPS guided. We also have infrared guiding, meaning that the bomb will arrive over the target area, basically take a picture of the target area, and then get to target with really good accuracy. Now, what we have here at the back of the bomb, it's booster and fins that will guide the bomb. So when you fire the bomb, actually, fins here will deploy from the bomb so as to keep it stable and guide the bomb to the target. But then you have a booster in there, which means that it will not get the bomb go faster. It's not like a missile. However, it will give the bomb extending range. With this bomb, you can fire up to 50 kilometers away from the threat, meaning that 50 kilometers away, there's no way the enemy will know that you're coming. There's no way they will ever be threatened, and yet they can still have 6 bombs arriving at the same time, coming from the same aircraft, 50 kilometers away from that. And what's really great is that you can bring up to 6 of these bombs at the same time, and you can fire to 6 different targets at the same time. So the pilots will just go one pickle, the 6 bombs will go off at the same time, and they will make their way autonomously to their targets.
What I've had a chance to see here in Saint-Dizier and on my sortie on the Rafale in East is the complete package. The Rafale as a battle-tested fighter aircraft. But where does it all begin? Design and development of aircraft, not just the Rafale, but also other jets now manufactured by Dassault, happens in places like this, the virtual reality centers in Paris.
While performing in
This is the first time any journalist has been given access to these areas. Many of these manufacturing processes are still top secret. But what I'm given an opportunity of seeing is what Dassault engineers see in a three-dimensional space. They literally design and fine-tune their aircraft in thin air, courtesy a state-of-the-art piece of software called CATIA. Well, you could be asking what I'm doing with a pair of dark glasses in my hand, but I can tell you that these aren't dark glasses, and the space I'm in is certainly not out in the sun. These are 3D goggles in a sense, far more advanced than what you'd see in a 3D cinema. And the space that I'm in, the environment I'm in, is what engineers at Dassault use to actually take a look in a three-dimensional space of the inside workings of the aircraft. So, Jerome, this technology which you have based on Dassault's own software enables you to get right into the heart of the aircraft. How does that help you as an engineer?
Yes, indeed. What you see here on screen, well, this is the exact mathematical virtual definition of the aircraft. Naturally, it enables us to enhance the design process. It really brings in some new design features because we can perform the complete design of all the structures and systems while performing in parallel complex mathematical simulations, simulating the airflow around the fuselage during flight by maths, checking the structural integrity of the aircraft and so forth. But at the same time, in parallel, we can prepare all the industrialization, manufacturing, assembly of the aircraft, because this digital mock-up is also the reference, the unique database of the aircraft, which is shared between all. And beyond design, beyond manufacturing, we can also prepare at the same time, I would say, the complete life cycle of the airplane, understanding in advance maintenance activities, customer support, ergonomics and so forth. So it enables us to capture upfront and optimize as best as we can the overall configuration of the aircraft.
There are other areas as well at Dassault's Design Hub where the Rafale is developed. The Immersive Reality Center takes the entire process of design and development of aircraft like the Rafale to the next level. Now, I'm wearing all of these unusual things on my arms, on my waist as well, because these are all sensors, and I'm going to step into the cockpit of the Rafale fighter. That's right, the cockpit of the Rafale fighter, but there's one important difference. It doesn't exist. Now, courtesy the sensors which are on my arms and on my eyes, what I see now is the exact replica of the cockpit of the Rafale in which I'm located. Now, that's me over there on the big monitor. I'm waving at you, and as you can see, I'm turning my head, and it's doing exactly as I'm doing. One of the key aspects in designing modern aircraft is the man-machine interface, MMI as it's known. And the ergonomics of the cockpit are essential. Is it comfortable for the pilot? Is there enough space for the pilot to move? Is there enough ability for the pilot to actually reach out to certain consoles, to certain buttons? And can the pilot do this in, say, a combat situation? So that's where this three-dimensional world, this virtual world, actually enables designers to work very effectively. Now, as you know, engineers love to measure things. Now, one of the things that this particular software enables me to do is to measure anything I want within the cockpit. So take a look at this. If I'm to measure the distance between the left-hand multifunction display, that's this console over here, and the end of the right-hand multifunction display over here, I just mark out the area and do that. Now, that's just in a sense two-dimensional. I can also do a three-dimensional measuring by just stretching this out like this to my ear. What's the distance between my ear and the left hand MFD? And so you've got an idea of the distance over there. So this is a virtual world. It's absolutely incredible, and I wish you could see exactly what I'm seeing, but if you see the movement of my arms and of my head, it's because I truly believe I'm immersed in this virtual world. If protracted negotiations finally end up in a contract, the Rafale will bring to the Indian Air Force the state-of-the-art in military aviation. While the Rafale is not a stealth fighter, in other words, it can be detected on radar, it has stealth features which make its radar signature very small. With a wide array of weaponry and a highly networked sensor suite, the Rafale will bring to the IAF a set of capabilities which our men in blue could only dream of a few years ago.